Okay, this is about day 2 note of Unit 6, Artificial Neural Network. So I'm going to explain the basic math. I'm going to start from the last class things. There is a question, kind of. Given z, we can also redefine f of x and y, so there are two variables. What is a change in z? We can use a partial f with respect to x times change in x plus partial f respect to y times change in y. Last time in the day 1 note, we already talked about this one we can also rewrite to vectorize them. So first vector has only partials, then second vector only change in x and change in y. So we can use a dot product of those two vectors. First vector, we call it gradient vector, so we can also use upside down triangle. We call it as nobla. So nobla f means partial respect to each variable. Then change in x, change in y, we can think about this one is changeable, so each time we can use a different values. So we are going to say this one as a directional vector. So first one, partial, the derivative values will be fixed, but second vector, we can change it, so flexible. Whenever we have the nobla gradient vector with directional vector, we can move toward the positive way and negative way. If we are using the positive way, we are going to find the maximum. So finally, we are going to go to the positive direction. Then if we want to find the minimum, we are going to go to the negative direction. So find the minimum value. Example 1. Now we can apply the directional vector with the different values. So when you have 2x plus 3y, when x changes by 1, how much z will change by? So we are gonna find the partial respect to x and partial respect to y. So partial respect to x is 2 because 3y does not have any x, so it becomes 0. So derivative of 2x plus 3y respect to y will be just 3. Then there's a change in x by 1 but no change in y. That means you are gonna put the change in y as 0. So you are gonna have partial respect to x value 2 times change in x 1 plus partial respect to y, that is 3, but change times change in y as 0. So finally z will change by 2. How about if y also changes by 1? In that case, you are going to multiply 1 to the 3, so you're going to get z changes by 5. Whenever we use a gradient vector, nobla f, and directional vector, we call that as a directional derivative. Now, and so that is a derivative, that means a slope, so that is a ratio, not the real value. Example 2 was one of the question in the day 1 note. So there are two equations, w equals something and y equals something. Then if you count all the variables, there's x, y, and w, so there are total 4 variables. So we can say that the dimension is 4. Then the number of dependent variables are also same as the number of equations. So normally, not always, but normally, so we are going to think about w and y as dependent variable. Then independent variable will be the number of dimensions, the number of all variables minus the number of dependent variables. So in this case, x and z will be independent variables. When you find partial w respect to x, it is possible because w is normally dependent because we considered w as dependent and x we considered as independent. So in this case, we can find the partial by using chain rule. But if you have two variables, like you can see on the right side bottom, independent variable, partial of independent z respect to independent x, you cannot get the derivative, so it's gonna be 0. So now let's use the chain rule, go back to the partial w respect to x. First, you can do respect to x and times the partial x respect to x again, so because we just want to use the same format for each one. Then partial respect to y times the partial y respect to x, because you finally need to do everything to respect to x, you are going to multiply. So if you look at here, you can also vectorize this one. Because of the first one, partial x respect to x, we can vectorize that. So I can also rewrite nobula f dot product with directional vector. Or yeah. But when we calculate that, we can just jump from the original one to just calculating partial f respect to x, so you're going to look at only x part. So x squared derivative is 2x and yx derivative respect to x is just y. So 2x plus y. Then x partial x over partial x is just 1, the same thing. Then plus partial y respect to y will be, you're going to look at just the y variables. Oh, there is yx, so x is the derivative of this one. Then times partial y respect to x, you can look at the second equation. So if you do derivative, that is 2x plus partial respect to z, so you're going to look at the just z. So derivative for z is 3z squared. But partial z respect to x is independent over independent, so it is 0. So if you simplify this one, you're going to get 2x squared plus 2x plus y. You can change y to x squared, or you can just keep y. In our comp sci class, we just prefer keeping y because we are going to define this y in a function.